Okay, so one more thing about electrons. And so this one we're talking about valence electrons. And so we're going to be able to use that electron configuration that we just learned in the last video to determine the number of valence electrons in an atom. Okay, so the electrons in the last energy level are called the valence electrons, okay, or valence, depends on who says it, right? So in this particular picture, there are 3 energy levels. That last energy level, the third one, has 1 electron in it. That is the valence electron, okay? It's these electrons that can participate in the formation of chemical bonds. So that's why it's important that we understand how many electrons we have to work with, okay? There are 2 ways to determine the number of electrons in an atom. The first way is to use the electron configuration that we just learned, right? So we have a sodium atom, and in our sodium atom, the electron configuration is 1s2, 2s2, 2p6, and 3s1. Or we could put neon, Ne, and then 3s1. What we do is we look at that last energy level number, right? So in this case, our last energy level is 3. So we look for that number, and here's our 3. And we add up all the electrons that have that first indicator. So 3s1, that means that sodium has 1 valence electron. Okay, let's look at another one. If our next one is gallium, okay, gallium has 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and 4p1. Okay, so if we're looking at it, our last level is the 4th level, right? If we look, there's a 1, a 2, a 3, and a 4. What we want to do is we want to count the electrons that have the 4 starting. So I have a 4 here and there are 2, and I have a 4 here and there's 1, right? If we look at the short notation, I have a 4 and a 4. We don't count the 3D, right? We only count the 4. So gallium has 3 valence electrons, okay? The second way to determine the valence electrons in an atom is to look at the periodic table. The number of valence electrons corresponds to the column number that the element is in. So if we look, these numbers across here are column numbers, except we're going to change them up just a little bit. So column 1 and 2 are going to stay the same. But when we get over to column 13, we're going to start over and say that that's a 3, right? So we have 1, 2, skip this middle part, and then you have 3, 4, 5, 6, 7, and 8, okay? The reason why we skip this middle part is because those are what's called the transition metals, and they don't necessarily follow this rule. And so rather than using the numbers that are on top, what I'd like for you to do is I'd like for you to write the numbers down here on the bottom of your periodic table so that you can come back and look at it. So for example, we said gallium has 3 valence electrons. 3 valence electrons, okay? Before we were looking at sodium. Here is sodium. Sodium's in the first column, so it has 1 valence electron. If we were to look at argon, argon is in the 8th column, therefore it has 8 valence electrons, okay? So you should now be able to use the electron configuration or the periodic table to determine how many valence electrons there are in an atom. Dot structure, or just dot structure. Basically, if you take the valence electrons and represent them in as dots around the symbol, you have the Lewis dot structure. And these are going to be helpful for when we're actually working with bonding and putting more than one atom together. Okay. But we're going to introduce them here because we're using the valence electrons. Okay. So to draw the dot structure of an atom, first thing you do is write the symbol for the element, right? So if we were to be doing lithium, we would write Li, and then we would place dots around the symbol in the shape of a square. And so that there's like 2 on each side of the square. Okay. So with lithium, there is one electron, one valence electron. So we would just put one dot. Now, it doesn't matter where you're putting that dot as long as it's on one of the 4 sides of a box. Okay. For example, here's carbon. Carbon has 4 valence electrons. So we put one dot around each side of the box to show that there are 4. Um, uh, Oxygen has 6. So we have 2 on this side of the box, 2 on this side of the box, 1 here and 1 here. Is it wrong to do 2, 4, and then do 2 here? No. It just doesn't show that we have a full, like the box, right? It really doesn't matter where you put them as long as you don't have more than 2 on each side of the box. Okay. If you have more than 8, then you've done it wrong because there should only ever be 8 dots or 8 valence electrons. Okay, so that would be the second part of the valence electron practice.